So today we're going to be continuing part 5, and we're going to actually do some factoring proofs. So we're not just going to practice factoring, we're actually going to use factoring in some proofs. So just a little recap. In our last video and yesterday, we focused mainly on greatest common factor. That's just factoring out a common piece from each term. Undistributing is another way to word it. We also factored using the trinomial where a equals 1 method, which is basically where you have something that kind of looks like this. You have a sine or cosine, whatever, squared, minus or plus another one of those trig functions, plus a number, and you can factor it that way. And then the last method we talked about was difference of perfect squares. This pops up quite a bit. Because it's also kind of related to the Pythagorean identities. So if you look at this, this is actually a manipulation of the Pythagorean identity. So say you had cosine squared x. Well, then you could change that into this, and then you could factor that into two pieces. So this goes pretty much hand in hand with the Pythagorean identity. So this one's very useful as well. So if we come over here to page 60, let's go ahead and work out an example. It's going to be secant to the fourth x minus 1 equals sine squared x plus sine squared x cosine squared x all over cosine to the fourth x. So that is a big, giant mess. Obviously, we're going to start with the right-hand side because that's the more complicated side. So we're going to say, all right, well, we've got sine squared x plus sine squared x cosine squared x all over cosine to the fourth x. And I can see that we've got two terms on top, and they both have a sine squared x in them. So I'm going to factor that out. So now I'm going to have sine squared x times what's left over, 1 plus cosine squared x divided by cosine to the fourth x. And what we're going for is a secant to the fourth. So now I've got this going on. Let's see. There's a couple different things I can do here. What I notice is that I've got